Hi Biobombs, it's Anshika. Today we're going to be discussing Chemistry of Life Part 2. Today's topics include pH, ocean acidification, functional groups, carbon, and isomers. So let's get started with pH. Our pH scale ranges from 1 through 14, with a high H+ concentration at 1 and a gradual decrease until 14. The solution is acidic from 1 through 6, neutral at 7, and basic from 8 through 14. An example of a neutral solution is water, an example of an acidic solution is citric acid, and cleaning solutions are basic. An example of a buffer is carbonic acid, H2CO3. The equation for carbonic acid creates bicarbonate and a hydrogen ion. Since this is a reversible reaction, the bicarbonate and hydrogen ion can also go back to create carbonic acid. The direction of the equation depends on whether it is too acidic or too basic. If it needs more H+, it will go towards the right in order to release more hydrogen ions, which, as we said before, decreases the pH. If the solution is too acidic, we need to take away the H+, and in order to do that, we create carbonic acid. Today, something called ocean acidification occurs. When this happens, it alters the balance of the conditions in the ocean. Because we have an increase in greenhouse gases, this includes CO2, it dissolves in seawater and reacts with the water there to form carbonic acid, which lowers the ocean's pH. Okay, so now let's move on to functional groups. They're very important chemical groups that have specific properties, chemical properties. So let's start with hydroxyl. They are mostly alcohols and they are polar. Carbonyl is basic and polar, and normally it is present in carbs. Then carboxyl is acidic, and it is found in amino acids. Amino is basic, and it is also found in amino acids. Sulfhydryl is found in rubber. Phosphate is very important, and it is found in ATP. It's acidic, and it is polar. And the last one is methyl, which occurs during methylation, which is when DNA is tighter. So when these methyl functional groups attach to DNA, DNA wounds tighter, so it's harder for it to be transcribed, and it's also nonpolar. These functional groups are the 7 main ones that you should memorize for AP Biology. Moving on to carbon, it is an essential element. Any compound with carbon is an organic compound. It can form up to 4 covalent bonds because it has 4 valence electrons. Variation in carbon skeleton creates molecular complexity, which is that different compounds because of their different structures. So moving on to hydrocarbons, they only have hydrogen and carbon, and they are special because of that. These are very prominent and found almost everywhere in life. In this diagram over here, you can see that carbon is sharing its 4 valence electrons with the 2 oxygens to create double bonds. The last topic we will be discussing for this video is isomers. They are molecules with the same number of atoms but different structures and properties. So there are 3 main types of isomers: structural isomers, and they have different covalent arrangements of their atoms; cis-trans isomers, the covalent bonds differ in their spatial arrangements; enantiomers, which are mirror images and differ in shape due to asymmetric carbon. So the diagram below shows a cis and trans isomer. So as you can see, they're mirror images of each other. Thanks for watching! Stay tuned for more biology videos.